Hello guys, and welcome to our channel. In this video, we're going to talk about cheese processing. I know many of you are asking, how is cheese processed? Processed cheese is produced by blending shredded natural cheese of varying maturity with emulsifying salts and other ingredients. The mixture is heated with continuous agitation until a homogeneous plastic mass is obtained. Processed cheese is made from natural cheeses that may vary in degree of sharpness of flavor. Natural cheeses are shredded and heated to a molten mass. The molten mass of protein, water, and oil is emulsified during heating with suitable emulsifying salts to produce a stable oil and water emulsion. Processed cheeses typically cost less than natural cheeses. They have a longer, somewhat limited, because earlier research has been done in companies and held as trade secrets or were protected by United States patents. Today, almost all initial patents on processed cheese have expired, providing opportunities for new developments. There's been renewed interest in processed cheese due to the food industry's need for tailor-made cheeses with consistent quality and functionality, as well as consumer needs for cheese products beyond natural cheeses. Processed cheese provides an opportunity to meet these needs. Today, processed cheese is one of the leading cheese varieties worldwide. Here is some historical background of cheese. Cheese is an ancient food whose origins predate recorded history. There is no conclusive evidence indicating where cheese making originated, whether in Europe, Central Asia, or the Middle East. Earliest proposed dates for the origin of cheese making range around 8000 BCE, when sheep were first domesticated. Since animal skins and inflated internal organs have, since ancient times, provided storage vessels for a range of foodstuffs, it's probable that the process of cheese making and salting of curded milk to preserve it. Observation that the effect of making cheese in an animal's stomach gave more solid and better textured curds may have led to the deliberate addition of rennet. Early archaeological evidence of Egyptian cheese has been found in Egyptian tomb murals, dating back to 2000 BCE. A Greek cheese. Cheese produced in Europe, where climates are cooler than the Middle East, required less salt for preservation. With less salt and acidity, the cheese became a suitable environment for useful microbes and molds, giving aged cheeses their respective flavors. The earliest ever discovered preserved cheese was found in the Taklamakan Desert in Xinjiang, China, dating back as early as 1650 BCE, 3600 years before present. Next, we'll talk about the development of cheese industrial processing technologies and its advantages. In contrast, the main forces that drive cheese technology are economics, equipment and engineering, consumer demands, and regulatory standards. In addition, production of consistent and high-quality cheese while maintaining high-volume throughput is a key challenge in cheese. Adoption of process analytical technology for continuous monitoring and control of relevant processing parameters in dairy processing minimizes the production of low-quality product and increases productivity and profitability. Alternative processes for the reduction of bacterial load include the use of specially designed centrifuges or microfiltration, hydrogen peroxide/catalase treatment of milk, and bactofugation, a high-speed centrifuge, could be used to remove bacteria and bacterial spores from milk. More recently, adjusting the protein content of the milk through the use of ultrafiltration technology was able to achieve the desired final composition. Advantages include a more uniform starting material, profitable use of a lactose stream, and greater throughput of milk solids through the cheese vat. The choice of equipment for the vat stage of the cheese-making process depends on many external factors, including the type of cheese to be made, downstream curd processing, flexibility, cost, and throughput, to name a few. In recent years, new biotechnologies to promote cheese maturation and improve flavor have been explored frequently, including the inoculation of additional cultures and exogenous enzymes, and the impact of temperature and high pressure on the quality of the cheese. Instrumental technologies and sensory panels can be expensive and require trained personnel, warranting more innovative rapid detection systems for ripening monitoring and evaluation of cheese quality, such as infrared spectroscopy, electronic nose, and optical techniques. In order to increase customer acceptance of processed cheese products, manufacturers are often seeking new ways to increase their functionality. The main cheese fortification methods are through the incorporation of probiotics and prebiotics, vitamin enhancement, and fortification of the PC with other macronutrients. The development of dairy technology has allowed for the standardization of industrial production technology for some cheeses, whereas other cheeses are still prepared using the traditional non-standardized methods. For example, ultrafiltration and concentration technologies are more suitable for feta production, but Kazakh cheese is made using the traditional non-standardized manual processes. In addition, use of edible films and coatings in cheese preservation has opportunities and challenges. Do you want to make cheese of your own? Here are 10 steps for cheese processing or production. Number 1. Preparing the milk. Before it can be turned into cheese, the milk may need to be processed. Just like any dairy product, the first stage of cheese pasteurization starts at the dairy farm. Here, farmers milk the cows, a process that's been mechanized thanks to machines that mimic the hand movements of humans. Once the cows are milked, the milk is refrigerated for better protection and preservation. Then, the milk is analyzed to ensure it matches with the consumption standards. It is then loaded into isothermal tank trucks and delivered to the dairy plant, where it will be processed prior to its transformation into cheese. Number 2. Acidifying the milk. Adding cultures to the milk allows it to begin to ferment and makes it more acidic. This step in the cheese-making process is added to starter cultures to acidify the milk. If you've ever tasted sour milk, then you know that left long enough, milk will acidify on its own. Number 3. Curdling or coagulating the milk. Adding rennet causes a reaction that curdles the milk, creating curds. Coagulation is the process of transforming the liquid into a semi-solid. When making cheese, an enzyme called rennet is added either as a liquid or paste to further encourage the milk to solidify. Number 4. Cutting the curd. The cheesemaker cuts the curd with knives and heats it, further separating the curds and whey. As the milk solidifies, it forms curds and whey. The curds are the solid part and the whey is the liquid. In this step, the curds are cut using a knife or a tool that resembles a rake. Number 5. Processing the curd. Processing the curd through stirring, cooking, and washing continue to acidify and dry the curds. After being cut, the curd continues to be processed. This might involve cooking the curds, stirring the curds, or both. All of this processing is still aimed at the same goal of separating the curds and whey. In other words, the curds continue to acidify and release moisture as they're processed. The more the curds are cooked and stirred, the drier the cheese will be. Number 6. Draining the whey. Here, the whey is drained, leaving only a mat of cheese curds. Number 7. Cheddaring the cheese. The cheesemaker cuts the curd mat into sections and repeatedly flips the sections before milling the mat. With the whey drained, the curd should form a large slab. For some cheeses, another step remains to remove even more moisture from the curd. This step is known as cheddaring. Number 8. Salting the cheese. For some cheeses, the next step is dry salting, and for others it is brining. The curd is now beginning to look more like cheese in its final form. To add flavor, cheesemakers can salt or brine the cheese at this point. This can either involve sprinkling on dry salt or submerging the cheese into brine. An example of a cheese that gets soaked in brine is mozzarella. Drier cheeses will be dry salted. Number 9. Shaping the cheese. Cheesemakers shape the cheese, often using molds to assist. Number 10. Aging the cheese. Some cheeses are aged for anywhere from a number of days to a number of years. For some cheeses, the process is already finished, but for many cheeses, what's known as aging remains. Aging should occur in a controlled, cool environment. As the cheese ages, molecular changes take place that cause the cheese to harden and the flavor to intensify. The aging process can take anywhere from a few days to many years. In some cases, mold develops, which adds unique color and flavor to the cheese. Thank you for watching.